Welcome to this episode of Robert's Creative Chronicles. So today we are going to solve this question, which states that solve the following differential equations using method of separation of variables. So we'll start with the A part. So in the method of separation of variables, you have to express the left-hand side of this equation in terms of functions of y and the right-hand side in terms of function of x. So we are expected to do something like f of y dy equals p of x to x. So we'll put all the functions of y at the left-hand side of this equation, and we'll put all the functions of x at the right-hand side. So we have to rearrange this equation to give us something like this. So now we eliminate all the functions of y that are in this side, and we'll eliminate all the functions of x that are in this side, and we'll transfer everything to the other sides. So now let's eliminate this x. So to eliminate this x, we'll divide both sides by x, and to eliminate this y, we'll divide both sides by y. So let me divide both sides by y first. Y minus 3 over y. Then this dy is some function of y, so we are leaving it here. Then divide both sides by x, 4 x. Then this x, the x, you multiply both sides by the x. You multiply here by the x and the x will cancel. Then here will be the x. So 4 over x dx. We have successfully converted this into this function. So you have rearranged this equation to give you something like this. Then next, we integrate both sides. We integrate both sides of this equation. Integral of what? Y minus 3 over y dy equals integral of 4 over x. Now, to integrate this function, it's hard for you to integrate this function, so we have to divide both sides by y, so that we will simplify the function. So, and we'll open the bracket as we do that. It's integral of y over y dy minus 3 integral of 1 over y dy equals 4 integral of 1 over x. So this one gives us what? 1 dy minus 3 integral of 1 over y dy equals 4 integral of 1 over x. So we'll integrate now. This becomes what? Integral of the y is y minus integral of 1 over y is ln y. So it will be 3 ln y. Then this becomes 4 ln x. Then if you finish, you add plus c to this side, to the right hand side. So now you can leave it like this, it's also correct, this is the answer, or you can just say y equals 3 ln y plus 4 ln x plus c. So this is the answer for the A part. We have successfully used the method of separation of variables to solve this differential equation. Now the B part. So here is the B part. Now, in the same way, we are going to put all the functions of y at the left hand side and all the functions of x at the right hand side. So let's do this. Take this to the other side, it becomes minus x squared y plus 1. Then we'll now divide both sides by y plus 1. So I will bring it here. And we'll also divide both sides by x minus 1. So if we divide first by y plus 1, it becomes y squared over y plus 1 dy minus x squared over x minus 1 dx. So we have successfully rearranged it. And now we will integrate both sides. So to integrate this, we have to use the process of long division, because this function you cannot use substitution to integrate this, because it will not give you the answer. The only way, you have to use long division method. So let's do the long division method. The dividend is y squared. The divisor is y plus 1. Then let's do this. We can assume here is plus 0y. Y squared divided by y is what? Is y. Y times y is what? Y squared times 1. Y times 1 is what? Plus y. Then we minus it. So then we subtract it. This y squared minus y squared is 0. 0y minus y is minus y. So this divided by this is minus 1. So the minus 1 times this is what? Is minus y, then minus 1. Then we minus it again. This becomes positive y. Positive y minus y is 0. Then this becomes plus 1. So what will remain here is 1. So now this is our remainder. This is the quotient. So now this y square over y plus 1 equals what? Y minus 1 plus 1 over y plus 1. So this one now, if you solve this, you get this. You want me to test? This one, the LCM is y plus 1. Then multiplied by this one, it becomes y squared. This becomes minus 1 squared. Then this times this divided by this is 1 plus 1. So now this one becomes y minus 1 plus 1, y squared minus 1 plus 1 over y plus 1. So this one and this one will cancel. So it becomes y squared over y plus 1. So you see, so this is an equivalent form of this. So we can integrate that instead. So the integral now, integral of y minus 1 plus 1 over y 1 dy equals minus x squared over x minus 1 x. This also we have to use the process of long division. So x square, we'll leave the minus out. X square, x minus 1. So x square divided by x is what? It's x. Then you times it. X minus x, x square minus x. This plus 0x. 0 0x plus x is what? It's x. So this divided by this is what? Positive 1. Then this becomes x minus 1. This becomes, so 0x plus what? Plus 1. But this 0x, 0 times x is also 0. So this is also 0 plus 1. So it's 1. This x, there's no need for you to put it. So this is, so x minus x is 0, not 0x. So 0 plus 1, which is 1. So the remainder is 1. So now this equation can be written as what? Equals to what? X plus 1 plus 1 over x minus 1. So, and if you work it to give you, it will give you this one back, this x squared over x minus 1. So this is what we are going to integrate for this one. So now we will integrate those functions. Remember this minus from the beginning, this minus. You know, when we used long division method to express in another form, we did not include the minus. So now we have to put the minus, then we integrate it. Now this becomes integral of y is y squared over 2 minus y plus in y plus 1 equals integral of x is what? X squared over 2, but it's negative x squared over 2, this minus, then minus x minus then x minus 1 plus c. So now here is the answer. You can also rearrange it in any way you want, but this also is also correct. This arrangement form is also correct. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp, email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.